In the very popular Shakespeare play, Hamlet, we get the question to be or not to be. And that reminded me of this decision when we look at some word problems of to multiply or divide. That's the ultimate question, because these things are so similar that it sometimes is quite difficult to determine which operation that we should use. So in this video today, we are going to be looking at when we multiply and when we divide, as well as when we do multiple steps and occasionally some addition and subtraction. All right, let's look at our first problem. Number 1. Juan has a piano recital next month. Last week he practiced for 8 hours in the morning and 18 hours in the afternoon. Each practice session is 4 hours long. How many full practice sessions did Juan complete? Okay, so each practice session is 4 hours. So he had morning time, and he also had afternoon time. So we know that a full practice session would be 4 hours long. So we're trying to see, did he have any 4-hour blocks in the morning? And did he have any 4-hour blocks in the afternoon? And if so, how many did he have during those times? This definitely would be a division problem. But because I'm going to have to look at how many full sessions he had in the morning, and then add that to the number of full sessions he had in the afternoon, it is multi-step. And I'm going to be adding. So what I would first want to do is I'd want to take the total number of hours from the morning, and I'd divide that by 4 to see how many 4-hour sessions he had. And 8 divided by 4 would simply be 2. So there would be 2 in the morning. So I'll just put AM. Okay? And I'm going to add that to whatever I get for the number of 4-hour sessions he had in the afternoon. So there were a total of 18 hours that he spent practicing in the afternoons, and I'm going to also divide that by 4. Well, if I skip count by 4s, how many 4s can I pull out of 18? 4, 8, 12, 16. So then that would be 4 with a remainder of 2. So how many full practice sessions would there be in the afternoon? There would be just the 4. I can get rid of the remainder. I don't need that in this instance. So he would have 4 in the PM. So what I would now do is I would add 2 plus 4, which equals 6, and he would have had a total of 6 sessions. This is a problem that you need to solve, so please go ahead and solve it. In this problem, we are given the total, and notice I did not add 8 plus 18. I just wanted to make sure I pointed this out, because we're talking about full practice sessions, which would have meant the full 4-hour blocks. So this is a situation where I would not have added the 8 and 18 together and then divided by 4. I would have looked at the 8, divide that by 4, and then the 18, divide that by 4, and then add my 2 quotients. Pause this video if you didn't have a chance to write down what I did. Let's move on to the next problem. Number 2, this is another one we need to solve. Jim has a puppet pattern that calls for 5 feet of fleece. He has 22 feet of fleece. If he makes the greatest number of puppets, how much fleece will he have left? Now, a lot of times we look at a problem like this and we see how much will he have left, and we think automatically that's a subtraction problem. But we're going to read it again to make sure we understand what kind of problem this is. So, he has this pattern, and for the pattern, he needs 5 feet of fleece. He has a total of 22 feet. Okay, so we're trying to see if he makes the greatest number of puppets possible, which one of them would be 5, 2 puppets would require 10, 3 puppets would require 15, 4 puppets would require 20 feet. I can't go to a 5th puppet because he would have to have 25 feet. So now they're asking us how much is left. So this problem, someone may look at it as, well, he's going to only be able to use 20 feet, and so we'd be subtracting 22 minus 20. But understand, if you can see the 20, it's because you did division. Here was our actual problem. We really divided 22 by 5. And when we divided 22 by 5, we got 4 with the remainder, what was left over, the 2 feet. So how much fleece would be left over? We're looking at our remainder, which is 2 feet. This is, in fact, a division problem. If we really set it up correctly, this is a division problem. We divided 22 by 5, and what our answer was the remainder. That was our actual answer. We were looking at what would be left over. Go ahead and take your notes. Okay, I'm going to go to the next problem. Number 3, we're actually not going to solve this one, we're just going to talk about it. At a wedding reception, there are 69 people seated at tables. Each table seats 7 people. How many full tables are there? Okay, so we're thinking we have a wedding reception, and there's 69 people that get seated, and there are tables of 7. So a table can seat 7 people. How many full tables are you going to need? We are given the total, the 69 people. That is the total. Okay? And now we're figuring out how many full tables are there. This is, in fact, going to be a division problem. And I'm looking at 69 and I'm thinking about 7, and I know that 69 is not a multiple of 7, so we will have a remainder. So in this instance, I'm going to want just the quotient, and I'll drop the remainder because they're asking me for full tables. So the problem I would be solving here would be 69 divided by 7. And I just want the quotient without the remainder. Okay, quickly jot that down. and we'll look at the next problem. Matt bought 6 hats for $14 each and 3 belts for $33 each. Those are expensive. How much change did he get from $200? Now, I'm looking at the problem, and he's getting hats as well as belts, and then I want to know the change he's going to get when he pays with $200. Now, the change, when I'm thinking about change, that is going to be a subtraction problem. When I see that he's getting multiples of things, like the 6 hats for 14 each, that tells me I'm going to multiply. The fact that he's getting hats and belts, that tells me I'm going to be adding. So there's quite a few steps here. I'm going to add, I'm going to subtract, and I'm going to multiply. I am not going to have to divide in this problem. Okay, so first I would figure out how much did he spend on hats. Well, he got 6 of them for $14 each. So I can multiply 14 times 6, which would be $84 for the hats. And then I can figure out how much did he spend on belts. Well, he got 3 belts for $33 each, so I'd be multiplying 33 times 3, which would be $99. Okay? Now I have to see how much did he spend altogether. I need to know how much he spent altogether because he's going to pay with a $200 bill, and I'm not going to be able to know the change if I don't know what his total was. So now I'm going to add $99 plus $84. 13, carry my 1, that's 17, 18. So now I see his total is $183. But I have to do the next step. I have to figure out how much change is he getting back. So now I'm going to take $200 and I'm going to subtract from that his total of $183. So this first 0 is going to be a 10, and then this 20 is going to now turn into the 19. Okay, the 20 being the 2 and the 0 that are in the hundreds and the tens place. So now I have 10 minus 3, which is 7. 9 minus 8 is 1. 1 minus nothing is 0. So his change is going to be $17. That is my final answer. So he will get $17 back. Go ahead and write that down if you haven't already. Okay, we're going to move on to number 5. In number 5, we see each row of peach trees has 36 trees. There are 11 rows. How many peach trees are there? They're asking how many are there. We don't already have the total. We're trying to figure out the total. The total is unknown. We don't know what it is yet, but we know that there are 36 trees in each row, and there are 11 rows. So this is a multiplication problem. We would be multiplying 36 times 11, and that will give us the number of peach trees. Next problem. Dan has 1,479 sports cards. Mason has 3 times as many sports cards as Dan. How many sports cards does Mason have? Now look, they told us how much Dan has, and then they said Mason has 3 times as many. So this problem is a multiplication problem because we're figuring out how many Mason has. And Mason has 3 times the amount that Dan has, which is 1,479. So this would be a multiplication problem. So you see I put on mine that 3 times 1,479 equals M. The M simply represents the number of cards Mason has. Make sure you jot that down. Okay, in number 7, this is another one we get to solve. Large flower pots weigh 25 pounds each. One crate holds 35 pots. What is the weight? So we're trying to figure out the weight of one crate of flower pots. Okay, well we know that one crate holds 35 pots, and each pot weighs, the flower pots weigh 25 pounds each. So this is a multiplication problem because I am imagining that there's going to be 35 sets of 25 pounds in this crate. So I would be multiplying 35 times 25. So I will use the old school method. 5 times 5 is 25. I carry my 2. And then 5 times 3 is 15 plus 2 would be 17. Now I come to my next row, put my placeholder 0, cross out my 2, and now I look at 2 times 5. That is 10. I carry my 1. 2 times 3 is 6, plus 1 would be 7. Now I add my 2 partial products, 5, 7, 8. So the total that I got would be 875 pounds. And we know that LBS is how I can write pounds. So this was simply a multiplication problem. Go ahead and take your notes. Okay, this next problem, Mrs. Joan orders pizzas for a class party. Each pizza has 8 slices. If there will be 36 people at the party, how many pizzas should Mrs. Joan order so that each person can have 1 slice? So we have 36 people, and they're going to each have 1 slice, so there's going to be 36 slices needed, okay? And each pizza has 8 slices. So this is going to be a division problem because we have the total. The 36 slices is our total. We'll be dividing 36 divided by 8 because it's asking how many pizzas should she order. We already have the total, but we know the total slices, we just don't know how many pizzas she's going to need. Now, what's going to happen, because 36 is not a multiple of 8, we're going to get we're going to have a remainder. As a matter of fact, we'll get 4 with a remainder of 2. In this kind of problem, our remainder is going to tell us that we need to add 1. What do you mean? We're going to round our quotient. We're going to add 1 to our quotient. Because if she just gets, oh, and I said remainder 2. I really meant to say it's going to be remainder of 4. Because if she really just gets 4 pizzas, that means 4 people are not going to have a slice. There will be 32 slices, but 4 people are going to be hungry. So that won't make sense. So she would add 1 to her remainder. Okay, let's look at the next problem. Glenn made 19 trays of 12 muffins each. Lori made 16 trays of 19 muffins each. How many more muffins did Lori make? Okay, looking at the problem, they're asking how many more. That tells me that there is some subtraction involved in this problem. But we would have to figure out how many muffins did Glenn make, and then how many muffins did Lori make. So I would first figure out Glenn's muffins. I'd multiply 19 times 12 to figure out Glenn's muffins. Then I would figure out Lori's muffins. To figure out her muffins, I would multiply 16 times 19. Just looking at these numbers, I know that Lori is going to make more. So whatever she gets, whatever her value is, I'm going to subtract that from Glenn's value. Okay? So it'd be 16 times 19 minus the product of 19 times 12. And then that would tell me how many more muffins Lori made. Boys and girls, from our homework, I hope that you all were able to better see some of these multiplication and division problems. One thing I really hope that you saw in this video is that it's important to visualize the problem. Visualize it. For some of us, the way that we're going to visualize it is that we have to say it out loud. We need to hear it. We need to hear what's going on, and then that kind of makes a mind movie for us. You can also draw a diagram. Think about whether or not you are given the total. If you're given the total and you have words like each in the problem, most likely it's going to be a problem where division is involved. Pay attention to the number of steps involved. There are lots of times when you're going to have a multi-step problem. And we've been going over those. We've been going over them all year. And they don't always get labeled like multi-step. So just look and see, are there some steps I need to be mindful of? And then you'll be super successful doing this work. I hope you enjoyed this video. Till next time, bye-bye. One last thing. I totally forgot to mention that number 9 was a multi-step problem and a multiplication problem. I may have said it, but I just didn't check it off on our sheet. So make sure you checked it off on your sheet. Take care. Bye-bye.